So has everyone had a good conference so far? Yeah, it's been pretty good. I've been very impressed. I've been very pleased. So we'll go ahead and get rolling. According to my clock, it's about 32 minutes after 1 o'clock. Thank you very much for coming. Again, my name is Thomas Cameron. I am the Chief Architect at Red Hat for the Central Region of the United States. You can see there's kind of an alphabet soup after my name. I am a Red Hat Certified Architect and Red Hat Certified Data Center Specialist, Red Hat Certified Security Specialist, Red Hat Certified Virtualization Administrator, and I'm also a Red Hat Certified Instructor and Examiner. So I actually teach these classes and give the exams on them and things like that. So I'm a fairly technical resource. I have learned, the longer that I've been at Red Hat, I've been at Red Hat for about 9.5 years now, and I have learned that every time I think I really have a good handle on technology, we make a new acquisition or release a new product, and I feel like Rain Man, yeah, definitely an excellent Linux admin, yeah. So my contact info is up there. You can follow me on Twitter at Thomas D. Cameron. Be aware that I misspelled my name. Awesome. Thomas D. Cameron. Wow, that's a special kind of skill right there. So I tweet on all kinds of stuff about, software freedom, personal freedom. I am from Texas and a big advocate of the Second Amendment. So if you are not an advocate of the Second Amendment, don't follow me. Just don't. And then my contact down at the bottom, Thomas at redhat.com. Yes, I've been at Red Hat for that long. It's kind of awesome. Been with Red Hat for about 9.5 years. So what we're going to be talking about today is Gluster. And I'll talk a little bit about the project, the upstream Gluster project. I'll talk about Red Hat and the Gluster project. We'll talk a little bit about what does Gluster do, how does it work, a little bit about the architecture behind it. And then I'll talk about how you need to install it. I'll show you how you prepare your file systems, how you install the packages. Then we'll get into configuration. We'll set up distributed file sharing, and we'll set up replicated file sharing. And then I'll talk a little bit about how you connect clients to your Gluster service. And then we'll open it up for questions. Although, honestly, I hate waiting until the end for questions. If you have any questions, don't hesitate to interrupt me and ask me. If I don't know the answer, I'll make something up. If I do know the answer, I'll answer you. All right. So what is Gluster? I think the thing to be aware of is that Gluster was actually an independent company, an independent project that was driven out of here in Sunnyvale, and then also with a development center in Bangalore, India. It was actually built by venture capital, or the company was put together by a venture capital organization, and Red Hat bought Gluster back in 2011. And you can read the history of the Gluster company there at the link at the bottom on Wikipedia. But this is one of a number of acquisitions that Red Hat has made over the last few years. We paid $136 million for the company. We paid $136 million for free software. And then we turned around and made sure that it continued to be free forever. So that's again one of a number of projects that we've done that with. In fact, I did a little back of the napkin analysis of all the acquisitions we've made just in the time that I've been at Red Hat. We spent about $1.8 billion in acquisitions to turn around and give that software away to the community for free. So shameless plug for Red Hat. One of the reasons that I work there is because we are absolutely devoted to open source and very, very fortunate to do that for a living. So what is the Gluster technology? GlusterFS is an open source distributed file system capable of scaling to several petabytes. Actually, the theoretical limit for Gluster is 72 brontobytes. Does anyone know, can you get from gigabytes to brontobytes? Does anyone know that progression? Right, so it's gigabytes, it's terabytes, petabytes, exabytes, yottabytes, very good. And then, sottabytes, and then brontobytes, and then there's supposedly one past that that's like insanity bytes. I don't know, something crazy. But anyway, so the cool thing about Gluster is it scales. It scales ridiculously large. You're going to run into laws of physics problems, like literally being able to have enough bandwidth, enough cabling, and things like that. You're going to run into problems with your infrastructure long before you're going to run out of namespace with Gluster. So it's super, super big, and it's also really flexible. So with Gluster, if you interconnect your systems with just plain old, gig Ethernet, that works fine. You can do this over TCP. If you use something like InfiniBand, you can do this over RDMA as well. So it's very, very flexible. When you start talking RDMA, right, you're talking about direct memory access. It's silly fast. Anyone? Okay, geek contest. Anyone got InfiniBand in their environments? Anyone got InfiniBand at home? I do. I have 20 gig InfiniBand in my home network. I found a guy who is liquidating a bunch of surplus equipment from a university. It's only 20 gig InfiniBand, and I think they're up to like 40 or 54. So it's old, cheap InfiniBand, but yeah, I got InfiniBand in my home office. So anyway, doing this over RDMA is noticeably like seat of the pants faster when you're doing it. So it's very, very cool. It's very flexible. The architecture is, you've got the Gluster virtual storage pool. This is actually storage which is distributed across multiple physical servers or VMs or AWS instances or whatever. So you got a whole stack of machines here, and then they present all of those disparate storage components as a single namespace. And I'll show you an example of that in a little while. And then you share that out across your network to all the clients and applications. So it's super, super distributed, and you'll see it's actually really simple to set up. GlusterFS supports standard clients running standard applications over any network, any IP or RDMA network. That figure above just shows how users can access application data and files in a global namespace. And the thing about it is really, really awesomely fast when you distribute across multiple machines if you use the native Gluster client, because essentially you're getting kind of the same benefit that we used to talk about with RAID, right? Lots of writes across multiple spindles. Well, now we're doing lots of writes across multiple servers. So instead of being RAID, I guess it's race, redundant to the array of inexpensive servers. I don't know. Anyway. So, and it's open source, right? I am doing this presentation on Fedora 21. Red Hat has a commercially supported offering that's available via subscription. But if you want to use it for free out of the community, more power to you. We love you. Keep doing it. That's good stuff. All right, so the attributes of the GlusterFS namespace include scalability and performance. Potentially, these slides are going to be available, man. You can take pictures all you want, but you can have the slide deck. Potentially high availability, depending on how you configure it, and I'll show you how to do that in a little while. That global namespace, like I said, you make one mount to one mount point, and the Gluster client is smart enough to then extrapolate from there where your data is in the cluster. It's really cool. I'll show you some examples of that. An elastic hash algorithm. This is actually really important, and this is a technical differentiator between what Gluster does and what some other distributed file systems out there do. A lot of distributed file systems will have a node or multiple nodes which are metadata managers, right? And that metadata is what host is my data on, what the directory path is, and things like that. The downside of having a metadata manager node or nodes is those are single points of failure. If your metadata management node goes down, go take a coffee break while you restore, because it's going to be a long day, and your phone's probably going to be lighting up, and your pager's going to be going. Pager, listen to me, I'm dating myself. You're going to be getting text messages on your phone, so it's going to be a bad day. So the neat thing about the way that Gluster does it is every one of the machines actually understands, based on a whole range of values, but the cluster name, the host name, the directory tree, timestamps, there's all kinds of things that go into this algorithm that makes up the map of where files are located. So the cool thing is, if I've got a node, a client node that's running the Gluster client software, and I want to go look a file up, I don't have to go out and ask a metadata manager. I just figure out what the hash is for it, and that tells me exactly where to go in the cluster. So your access times are low, and the reliability is high, because if you lose a device, if you lose a node, you may lose the data that's on that node, but your whole cluster doesn't go down if it's a metadata node. So we don't have those. And then the Elastic Volume Manager, I'll actually show you an example of that, how to extend out a volume while the file system is live and mounted. And it is standards-based. These are all using, POSIX and other network protocols that are really easy to understand. So what do I do with Gluster? Gluster, the short answer is it's a software-based NAS. That's really what it does. It's software-based network-attached storage. You can serve Linux clients using the native Gluster client. You can serve Unix clients using NFS, and you can serve Windows clients using SMB. Now, there are some challenges if you want to mix, for instance, NFS. Would you mind closing that door for me, sir? Thank you. All right. Okay. So there are some challenges if you're going to be using NFS and SMB. I've run into a ton of shops that do it, and usually it's not a problem. But NFS locking and SMB locking are potentially, they can potentially conflict. So you can get some really weird states where a Windows machine will have a file locked or data within a file locked, but the NFS client doesn't realize it because they handle locking differently, and then you clobber your files, right? So be aware that that's a, yeah. Same file, yeah. Yeah, so it's kind of rare, right? I mean, you have to actually have a Unix client and a Windows client actually accessing the same file at the same time, so the chances are fairly low, but just be aware that it happens. And it's one of those things when it happens, no one realizes. Like, the Unix guys don't even realize the Windows guys were doing their thing, and they're like, all of a sudden my file just blew up or got truncated or something, so just be aware of that. Now, use case is unstructured data. So unstructured data is things like, I got a customer that's using this for medical imaging. You know, they're generating X-ray images and MRI images and CAT scan images and all these crazy images. Raise your hand if you work in an enterprise environment and your storage needs are going down next year. Didn't think so, right? Raise your hand if you're in an enterprise environment and you're going, holy crap, how am I going to keep up with my storage needs for next year? That's the typical thing, right? So everybody's generating all this data, whether it's log file data, it's home directory data, it's images for web farms or web content or medical imaging. I live in Texas, right? What's big in Texas? Oil and gas. What does oil and gas do? They don't make oil and gas. They make data. I swear to God, that's all they do. They have these massive geophysical storage environments. That's a perfect use case for this kind of environment, right? Cheap machine with lots of cheap disks that you can just keep stacking them up. Maybe your second or third generation old systems, right? You stack those bad boys up and put a whole bunch of cheap disks in them. You can grow your storage really quickly and really cheaply that way. So, but my point here is we're talking about unstructured data. This is not designed for use with structured data like database files. So if you've got a Postgres or an Oracle or a MySQL type of environment, you probably don't want to run that on your Gluster file system, okay? Now, having said that, I run virtual machines that are backed by Gluster all the time, and inside of those VMs, I've run databases, and I've never, ever had a problem. It's not a recommended best case or best practice, so your mileage may vary. Yes, sir? Mm-hmm. So I'm going to tell you Thomas's opinion. This is not the official story. I've used it with structured data. I've used Gluster with structured data a lot, and I haven't run into problems with it. We are super conservative when it comes to recommended use cases. Because of the way that you have the potential of doing replicated data, you can potentially take timeouts, you know, because we don't return control back to the application until we verify rights, depending on how you have it set up. If you have a database file that all of a sudden hangs because there's a slow write out to one of the machines, you can run into weird things like the database will get marked as offline, or, you know, you can run into all these really weird issues. I have not personally ever seen it happen, but we do have Bugzilla, you know, we do have bug reports of it having happened. So to be very conservative and very safe, we say it's not a recommended use case. Can you do it? I do it all the time. I do it all the time in little proofs of concept and demos and stuff. I wouldn't tell a big enterprise customer to do it. All right. So how does all this stuff work? Well, there's a couple of concepts you need to be familiar with. You're going to create file systems, and those file systems will be used when we define a brick. The brick is the smallest unit of storage in your Gluster environment. It's just a directory. It's nothing fancy, right? You can have a whole bunch of different bricks. You add bricks to volumes, and you can do this a number of different ways, and I'll show you a couple of ways in a little while. And then once you've gotten the volume set up, then you export that volume, you start the volume, and it becomes available to other servers or other machines out there, and you can connect to it one of three ways. The native Gluster client, which is the best way to do it because it uses that hashing algorithm that I was talking about earlier, so it does a direct write out to the machine where your data lives, or read. So that's the best way, but you can also use NFS for legacy Unix environments. You can even use Samba for CIFS environments or SMB environments. So a little bit about this demo. I was going to do live demo, but like I said, the screen real estate is simply not big enough to actually show you in an effective way, so I did screenshots. I had 4 VMs that I call servers. Okay, they're the ones upon which I install the Gluster software. Each one of these server VMs has an 8 gig root drive and an 8 gig drive that's going to be used as Gluster storage. Little gotcha. I had forgotten about this when I set the lab up. You can clone VMs, right? Cloning VMs is awesome. Clone the VM before you install the Gluster software, or be aware of the fact that the first time you fire the Gluster software up, it will create a glusterd.info file under varlib gluster that has a UUID in it. So if you clone the UUID multiple times, like you have a whole bunch of VMs, all of a sudden they all come up and they're all like, no, I'm Fred. No, I'm Fred. No, I'm Fred. So yeah, it's, yeah. Use the native Gluster client wherever you can. If you're doing Linux to Linux, just use the Gluster client. It's super, super fast. Yeah. Is it SE Linux aware? Aware? Yes. Actually, this should work with SE Linux. If you know anything about me, you know that I present on SE Linux every year at Red Hat Summit. I'm like a big SE Linux advocate. So far, even in the community upstream stuff, I've only run into like 2 small issues with SE Linux, and it was fixed by a RestoreCon. But does it hold the attributes? You know, like NFS 4.1. So no, we don't offer tagged network access like you can with NFS v4. But the underlying file system should be XFS, and XFS does support extended attributes, so you can do SE Linux on the file system. Yeah. And I don't know what the roadmap is for that. Thank you for asking me. I'll look it up. I'll look that up. All right. So anyway, so don't clone. We talked about that. All right. So first steps that we need to do is we need to create a partition upon which you will create the Gluster bricks. In the real world, you're going to use inexpensive servers because that's a big benefit is you can use commodity hardware. But in the real world, of course, we would recommend that you do some sort of redundancy at the server level, right? You're going to want to run a RAID 6 array or RAID 10, something like that. RAID 5 is going to take a performance hit. RAID 6 needs to be a little bit faster. So anyway, for this demo, I'm just using simple VMs with just simple partitions. So can y'all see that okay? Yes. Could you use JBOD for that? Absolutely. Absolutely. If you're going to use JBODs that don't have any logic in them, there's 2 ways you can do it, right? You can plug it into a cheap RAID card, and most enterprise class hardware is going to come with RAID cards. So I would say just attach it to the RAID card if the RAID card accepts it. But if that doesn't work, software RAID works pretty well. I mean, I'm not a huge fan of using that for enterprise space just because, you know, the hardware-based devices have a lot more diagnostics and a lot more, you know, analytics for pre-failure, and, you know, it's a lot easier in some cases to pull out a pluggable drive and plug another one in and just let the RAID controller handle with rebuilding it. But if you want to do software RAID, that's perfectly acceptable. Sorry? I don't touch ZFS, sorry. It is incompatible with our licensing scheme. CDDL is evil. Sorry, was that my outside voice? So you guys probably all know fdisk, so I'm not going to spend a whole lot of time on this except to say we're going to fdisk the partition, create a new partition, make it a primary. You can do extended, it doesn't matter. The point is you want to have a partition. And you'll see that when I get done, I've got this partition that's an 8 gig partition. Remember I said I've got that second drive that I'm going to use for my bricks? So I do that on the first machine, it works. I replicate that on all the machines, and that's an eye chart. You don't need to worry about what's on it except to say that I did the same thing on all 4 of them, right? So now I've got 4 partitions that are set up, 1 on each server, and then we're going to make a file system on it. We do recommend that you use XFS. XFS is very flexible. It handles a whole lot of little files pretty well, but it also handles big files pretty well. So it's kind of the least evil of the Linux file systems when you have a really varied potential workload. So we use XFS as the underlying file system with 512-byte inode size. And the way that you do that is makefs.xfs-i size equals 512, and then whatever partition you're going to make, right? You guys have all done this. And then I'm just demonstrating here that I did the same thing across all 4 of my nodes. So now I have 4 XFS volumes, or 4 XFS formatted drives. Create a mount point where we'll create the brick, and don't create the brick at the root of the mount point. You know how you can mount /dev/vdb1 on /mount/gluster? Don't make that the root of your brick. Do /mount/gluster/brick or /mybrick or whatever you want to call it. It doesn't matter, but don't do it in the root of the block, because then you run into some really weird things if you want to recreate volumes where it's written metadata to the disk that you can't physically see or remove, and you wind up having to reformat it. Kind of a bad day. If you do it into a subdirectory and you want to nuke that volume and start over, you just delete the directory. All right, so all I did was I created a directory called /export/vdb1, made sure that everything was in there, did that across all 4 of the machines, because remember, you want to replicate what you're doing across all of your Gluster nodes. And then I mounted that block device under /export/vdb1, and under that mounted block device, I made a directory called brick. So I make sure that that's all there, everything's good. I do that across all of my machines. And then we're going to add that mount point to /etcfs tab to make sure that it mounts when we boot up the next time. Fairly straightforward. Now, I cheat horribly. I'm lazy. I'm a terrible typist. I will make fat-fingered typos if given any opportunity whatsoever. So I use the /etcmtab file. I just do a tail-1 of /etcmtab /etsy/mtab, because that'll give you all the mount options. And then I redirect that out into /etcfs tab. Lazy. But it works great, and it always, and you know your syntax is right, because it's what the system did last time you mounted it. So anyway, you do that across all 4 of the machines, just like I was talking about earlier. Now that we've got all of our file systems laid out, now we want to install some software. And it's actually really straightforward. The command that you want to use is yum install GlusterFS. You can do these as separate commands, or you can do the array like this, -server, -fuse, and -georeplication. That will drag in all the other stuff that you need. The RPM dependencies will drag that stuff in. Now, if you're on Debian, you'll use apt-get. If you're on Gentoo, good luck. You can do just use your package management system. I used Fedora, but this is available across all the distros. So anyway, you do that installation, and it's going to drag in all the dependencies behind it. You'll see that it installs the GlusterFS server, the GlusterFS CLI, the georeplication package, all that kind of good stuff gets dragged in. You, again, want to do that across all 4 of or however many systems you have. And then you want to make sure that the services are running. By default, the Gluster services should be turned on. In the Linux or in the Fedora world, it's called, we do system control enable service name. So you want to make sure that that's actually done. So I did system control restart GlusterD and system control restart GlusterFSD. And then we check status on them, make sure that they're actually running, and they are. Did I? Okay, yeah. So the GlusterD service is for elastic volume management, and GlusterFSD is the actual Gluster service. So you want to make sure that those are turned on, like I said, check config or system control them. Now we got to tell the nodes about the other nodes. We got to tell them about their place in the world, and the way that we do that is we do Gluster, peer, probe, and then the node that we want to probe. You repeat that for each one of the nodes on there. If you got a whole bunch of nodes, I'd do a for loop, for I in sequence 1 through 10, do blah, blah, blah. But anyway, this is what that looks like, right? So what I did here was I did Gluster peer status, and you see there's nothing there. So then I do Gluster peer probe, Gluster 2, Gluster 3, Gluster 4. Now when I do Gluster peer status, you can see that I've got all of the nodes on there. It automatically considers itself as a peer node. So we've gone from nothing to I know about all the other nodes that are out there, right? It's real simple. Gluster peer probe, and we're hanging out. The thing that I wanted to point out on this one is I did all of the connections over here. And this is kind of hard to read, but take my word for it. We said status here. There was nothing that it was aware of. I ran all of these commands, and now all 3 of the nodes. So this is not a command that you have to run on all the nodes. You do it once from a central location. All of the nodes become members of the Gluster environment, and you're good. So now that we've got our file system laid down, we've got the Gluster node, the Gluster cluster. I don't know why we did that, but the Gluster cluster is up and running, and everybody knows about each other. Now what we need to do is we're going to define our volume. We can kind of cheat and define the bricks when we define the volume. Usually if you manipulate bricks after the fact, you'll see the syntax for that. I'll show you that. Now, the syntax is Gluster volume create, and then the name that you want to give it. You can call it whatever you want. The replica and count, so replica 2 or replica 4, if you leave replica out, you would just make a standard distributed environment where if you have 2 servers and you write 2 files, one will go to one and one will go to the other, right? That's distributed. If you want it replicated for redundancy, then you'd say replica 2 or whatever. You can define the transport, so TCP or RDMA, and then the host name and the path to the brick, the next host name and the path to the next brick. Now, in this first example, I leave replica out so that it's a distributed volume. Once you've defined the volume, you then have to start it. Now, when you start it, it stays started. That is persistent through reboots until you explicitly stop it. So Gluster volume start volume name, and then you could do Gluster volume info or Gluster volume info all. And so the way that that looks is I do Gluster volume info all, and you see there's no volumes present. So I'll do Gluster volume create test vol, transport TCP, because I don't have RDMA in my virtual machines. And I'm going to specify Gluster 1 / export / VDB / brick, and then Gluster 2 export VDB brick, or VDB1. And it says, yep, we're good. I created the volume. Please start it now. So I'll do Gluster volume start test vol, and it comes back and says, yes, we're good. Now, so up here we had Gluster volume info all said nothing. Here, Gluster volume info all shows the name of it. That is a distributed volume. So I'm going to write files equally across all the machines. Gives it the volume ID, what the status is, it is started, the number of bricks, the transport type, and what bricks are included. So it's pretty verbose. And that's it. We're up. We have a Gluster environment up and running. Pretty easy. I was almost disappointed that this talk got accepted over some of the other ones that I submitted, because this is like stupid easy. I mean, this takes like 5 minutes to set up a Gluster environment. Okay, I'm up and running. Thank you. Please drive through. You want fries with that? I don't know. But it's really, really easy to set up. Did you have a question, or are you stretching? Yep. In this configuration, yes. You can actually stripe files. We don't have time to do that. I didn't put that in, but yes, you can stripe files. Did you have a question?
Yeah. Sorry, I missed something. Is it something as effective as you leave replica out?
Mm-hmm. Then it's not a replicated volume, it's just a distributed volume. Remember I talked about you can do either distributed or replicated. Distributed or striped, but we're not going to get into the striped and the amount of. Right. So distributed means if I have 4 servers and I write 4 files, it's 1 per server. There's no redundancy. You got to do backup some other way. No. You lose one, you lose 1 file. The other 3 are still there. Because without replication. Because think about it, it's distributed, okay? I got 4 servers. I got 4 files. They're going to get written like this. Okay? If I lose 1 server, I lose 1 file, but the other 3 are still there. There's an algorithm for figuring it out. It's based on utilization. It's based on number count. There's a whole bunch of crazy magic that goes on under the hood, but it's not strictly round robin.
The files themselves won't get split up.
Correct, unless you choose a striped volume, which I'm not even going to get into today.
If you don't do that, then the maximum file size would be the smallest.
No, it is a combined size. So in this case, and I'll show you an example of this in just a second. I'll show you. Trust me, it works. But it's not there. Yeah. Yeah, you'll do an LS, and the cluster will come back and go, yeah, it's right over there. But over there is down.
So in practice, when you do that kind of setup, what happens when something tries to access it?
It comes back with a not found error.
And if you run stat on the file, will it give you the information that it has about it?
I've never tried. I don't know. It doesn't hang. It doesn't hang, because I've tried to do file access on files that aren't there, and it just comes back and it gives like a generic error.
For the replica?
Uh-huh.
So it's per volume, right?
Yes.
So does it get replicated to all your servers? Or all
Yes. All the bricks that are in the volume. So let's say I'm totally going off track now. This is awesome. So let's say I've got 4 servers like we have right here, right? And I'm going to have one volume that's distributed. So I'm going to do 4-way distribution. All right, 4 files. File 1, file 2, file 3, file 4, right? I lose this machine. File 1 and 2 and 3 are still there. File 4 is gone. Now, let's say on that same cluster, I got another volume that's going to be replicated. So now I've got a 2-way replica here and a 2-way replica here. So I write the file, it's going to get written to both of the nodes that are in the replica. If I do a 4-way replica, one file gets written 4 times. Boom, 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 boom. I can walk in with a hatchet and just chop the servers up, and there's going to be one of them that's still there, right? So it just depends on how you want to configure it. All right. So where was I? Oh, yeah. So again, this is an example of I set up the volume over here. The other nodes already know about it. I don't have to do anything on them. And of course, right now, there's nothing in the bricks, right? Because the bricks, I haven't written any files to them. So if I do an ls, and this is on one of the Gluster nodes, right? That's on server Gluster 1. If I go look at the actual path on the file system, there are no files there, which makes sense. So now what I'm going to do is from a client, in this case, it's from my laptop. This is a machine other than the 4 systems. I'm going to mount the file system. I'm going to mount the volume, okay? And the syntax there is mount-t GlusterFS server:_volume, and then where I'm going to mount it on the local path. It's just like NFS or SMBFS or whatever, right? So you mount the export, and then I'm going to test by writing some files to it. In this case, I just write 10 files for I in sequence of 1 through 10, do echo $, blah, blah, well, let me just show you. So I mount it. There's nothing there, but you see that I've got 16 gigs. I've got 16 gigs of usable space. Be aware that this is a lot like RAID, right? If I do a RAID 0, which is almost kind of what we're doing here, if I do a RAID 0 and 2 8-gig drives, I got 16 gigs. Unlike RAID 0, if I lose one of the drives, I'm going to at least keep half of my data in Gluster, right? Okay. So, and then what I do is I say for I in sequence of 1 through 10, echo that value out to a text file and done. And so I do an ls in /mount/Gluster, and I see files 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Does it look to me like those are on different servers? You can't tell from the client. But if I go look on those servers, you'll see about 1 over n of the files you just created in the brick directory, where n is the total number of replicas you have. Okay? So I'm going to go over here to Gluster 1 because that's one of my 2 nodes in my distributed environment. And when I do an ls, you can see I've got 5 of the files. That's on Gluster 1. If I go look at Gluster 2, I've got the other 5 of the files. Okay? So if I lose Gluster 1 or I lose Gluster 2, I'll lose half of my files, but the other ones will still be there. So that's the simplest way to do it. And the cool thing about that is it's fast. Okay? But it's not redundant. So do this if performance is really important to you and you have a good backup system. Don't do this if this is really critical, sensitive information. You absolutely positively can't take an outage while you restore stuff. In that case, what you want to do is replicate it. Yes, ma'am. Gluster works with everything. Yeah, you can back glance images. You can back Swift, Cinder. I think that's it. But yeah, this is just storage, right? I mean, this is just storage. And the whole point of this is we abstract what's underneath it. And the goal here is we want to make it as flexible as, you know, and as a backend for anything that you want. Yes, sir.
You had the client mount the first cluster.
Any of them. I could have actually done any of the 4.
Yeah, right. If you have 100 clients, should you be distributing that?
Doesn't matter. Because remember that the way that the client communicates with the server is it locally calculates using that hashing algorithm or using the placement algorithm where the file actually is out on which node. So if I want to retrieve 4 files and they're on 4 different servers, I make a separate TCP connection to each of the 4, and they can even run in parallel. So you can actually get some smoke and performance out of this if you're doing it distributed. Right. Yeah, there's literally no measurable difference of which I'm aware. Maps calculated locally. There's no metadata services here. Right. Okay, I see your point. Yes. When you first, well, not authenticate, but when you first make the connection, yes, then you're going to know about all the servers. But once that happens, that's cached locally, and from that point on, based on file name and host name and path, there's going to be it's going to calculate where that is, and it makes a direct connection. That it doesn't all go through one server and then redirect. No, no. Oh, I see what you're saying. So, like, if you lose connectivity and your topology changes, you would probably, just like any other network file system, probably want to reestablish that connection, and then it would get the updated listing of servers. Yes, sir. No, not today. This is a quick start, man. Sorry. So it's just a shared file system. So just like with NFS, right? Regular users aren't going to be able to mount it. Just like with NFS or SMBFS, typically you're not going to have regular users doing it. So right now, that's the only way of which I'm aware to set up access control. Mm-hmm. As far as I know, it's just open. You don't have access controls like you would in Etsy exports where you'd set, IP address or anything like that. I don't know if it's host access aware. I guess you could do hosts allow and hosts deny. I think it's compiled against the host access stuff, but I'd have to check. Oh yeah, absolutely. I mean, there's a zillion ways to protect your systems. All right, so I'm going to remove this volume and create a replicated one because we got to kind of get going. The way that we shut all this down is Gluster volume stop, and then the name of the volume that you want to stop, and it'll warn you, are you sure you want to do this, yes or no, and you hit yes. Once you do that, then you'll say Gluster volume delete test vol or whatever it is, and it's going to say, this is a one-way trip, kids. Are you sure you want to go? And you're going to say yes, and it's gone. So it deletes the volume. Now, what I have found is, like I said, there is actually some metadata that's stored in that directory. So I haven't figured out why yet. I'm sure it's documented somewhere. I just haven't found it. But if you try to create another volume on that brick, it'll go, nope, sorry, this brick is already allocated to some other volume. You're like, but I deleted that volume. So you can, I fought with the Gluster volume brick remove command, and it wouldn't work and wouldn't work and wouldn't work. So finally I was like, you know what? Big hammer, rm-rf, and then you create the directory or put a new directory structure, and it works just fine. So I delete it. I make the same directory again, and now this time we're going to do the Gluster volume create, but I'm going to use that replicas command, right? So I'm going to do Gluster volume create, testball2, transport TCP, replica 2, Gluster 1 export BDB1 brick, and Gluster 2 export BDB1 brick. And it'll say, okay, I made it. It's up and running. Go ahead and start the volume. So I do Gluster volume start testball2. It comes up. Life is good. We're going to do the same thing. We're going to mount that volume on a client. And this time, though, only 8 gigs are available. So from my laptop, I do mount-t GlusterFS, blah, 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 blah. I do a df-h, and this time it comes back as 7.8 gigs. Makes sense. We're essentially mirroring the content. We're replicating the content. So now instead of having 16 gigs, we have 8 gigs of space free. Now I'm going to create those 10 files for I in sequence 1 through 10, do echo, blah, blah, blah. And then I do an ls, and sure enough, I see my 10 files are there. It doesn't look like they're any different from anything else. I go over to the server, though, the Gluster server, and this time, when I do an ls of that brick directory, I see that I've got all 10 files there. So on Gluster 1, I've got all 10 files, and on Gluster 2, I've got all 10 files. So that's the difference between replicated and distributed. You do take a little bit of a performance hit by going with replicated, okay? Because we're writing each file twice now, and that happens from the client, okay? Parallel. If you run a netstat against it when you're doing writes, you'll see that it's actually got 2 TCP sessions open. So, but that means you're doubling network usage. That means you're doubling CPU usage. Now, on these, exactly. It's not bad, but it's there. Yeah. All right. So what if I suddenly realized, oh my gosh, I got to grow. I've got more stuff than I have space for. So you go down to the basement, you find one of these old machines that's not fast enough for your big production badass workload. You slap a whole stack of disks into it, you rack it and you stack it, and you create your file system and you add it to the Gluster environment. I talked to the head of a broadcasting company's IT department, and he was like, all we do all day, every day is generate, these big files, right? MP3s for podcasts, video files for TV shows, web content, all this craziness. He said, every time I have to get more storage, it takes an act of Congress. I've got to go fight with the storage team. It's just this horrible experience. Are you really telling me that I can go grab one of these crappy Dell boxes that have been, obsoleted by our current workload, but we've got pallets of them downstairs, and slap a bunch of disks in and grow my storage? And I was like, absolutely. And I showed him this on my little laptop. I spun up. I did exactly what I'm about to show you. And, his jaw almost hit the floor. He's like, I'll take 7 because I can go get storage this way now anytime I want, and it no longer becomes a fight with storage. So it was pretty awesome. So the command that I'm going to do here is gluster volume add brick. And I'm going to add a brick to test vol 2. Now I'm changing my replica to 4, okay? Because for whatever reason I'm insane and I want to have 4 replicas of my data. And I add the gluster 3 and the gluster 4 servers, and I come back and it says, okay, we're good. That's how hard it is to add storage. Raise your hand if that's too tough for you, because I think you're in the wrong place. It is. It's that easy. Super, super simple. Now, when I do gluster volume info, I can see that, again, I'm replicated, and it's across all 4 of those bricks. And when I look on gluster 1, I still see those 10 files there. But until the first write happens, we don't balance content to the other bricks. So right here, I do an ls on the new number 3 server, the gluster 3 server. There's no content in there. So this time I'm going to write some new files. I did 1 through 10 first. I'm going to do 11 through 20 next. So I do for in sequence of 11 through 20, do blah, 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 blah. I do an ls, boom, bing. All my files are there. I do an ls on the gluster 1 machine, and I see all 20 of my files. And I go over to gluster 3, and I do an ls, and I see all 20 of my files. Be aware that if you have a really, really, really mammothly large volume with a whole lot of files and you trigger this replication, you may take a performance hit. If you design your environment correctly, where you've got back-end networks like your InfiniBand networks for storage, this will happen on your back-end channel. Your customer experience should be as minimally affected as possible. So all that synchronization will happen on the back end. I'm sorry? Can it hash it? Oh, I see what you're saying. Not that I'm aware of. If you're going to have like a whole lot of files, then you're going to need to pay attention to how you build your directory structure. We don't do that for you. I don't think you would really want us to be saying, no. We know better than you how you should lay your file system out.
Well, I'm thinking about abstract. In other words, you have an actual file system in
Mm-hmm.
but it's actually presented in mouse cluster.
Mm-hmm.
So the point is, you would hash it in export DVD, whatever. It's still presented as the person created it in the file system.
Talk to me afterwards. Patches cheerfully accepted. Yes, sir.
One of your old Dell servers died.
Mm-hmm. 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 Yep. So if you're doing distributed, and we don't have time to do it because we've only got a few minutes left, but you can actually do like a mix of distributed and replicated. So I can say, okay, I want to replicate these 2 and then distribute those across these other 2. If you're doing replication, you can do gluster volume rebalance is the command. Gluster volume rebalance volume name, and it'll start doing that rebalancing on the back end. Correct. Right.
During that process, is the file system locked up, or is it?
Nope.
You can read right to it while it's going on?
You bet. It's just doing stuff in the background, and it does it asynchronously, and it does it in a way, like, it'll slow down the balance, and that's one thing to be aware of. If you do a rebalance, you know, you want to do it after hours, right, when people aren't there. If it runs over into the daytime, though, people come back in and they start hammering the file system, the rebalance will slow down. It'll throttle itself. Exactly. Yep. Yep. Okay. You have to run Gluster volume rebalance volume name status. Yeah, yeah. It usually happens pretty quickly because, you know, the whole goal here is we're going to have fast networking on the back end storage and hopefully relatively fast-ish disks, so it should happen pretty quickly. Just so. Yes, absolutely. Don't do it over NFS if you can possibly avoid it. Because with NFS, and I'll show you this in just a second. Actually, let me show you that in a second, okay? Somebody had a question back there? Mm-hmm. Well, it'll impact it. Yep. Yep. Yes. I don't know what you mean. Oh, you mean like for doing shadow copying and stuff like that? Yeah, that happens. Gluster doesn't do that. So the question is, can you integrate with Active Directory or LDAP or something like that? Yes, you can. You can actually set up SSSD, which is our authentication framework. You can point it at an Active Directory environment, so you can do all of your authentication against the AD environment. And then, you know, the file system, anything that gets written to that file system will be written with the UID and GID of the user or whatever your mapping is. But Gluster doesn't actually care about that. That happens at the authentication layer, not at the Gluster layer. Yeah. Oh, yeah. Yes, sir. It won't do it. Yeah, it won't do it. No, I think it would error out, actually. I think it'll error out. Yes. Mm-hmm. Yep. Yes, you can do Gluster volume brick dash move. So what you would do, so there's the way that the easiest way to do it is if you've got a spare machine, then you would do brick move over to that spare machine, drop this one, do your stuff, and then brick move it back. But honestly, I mean, you can do this live, like you can update the systems live, and that's what I would probably do. Yep.
One fun thing, you got four servers here, your client's mounting, probably using server one as a reference mount, right?
Mm-hmm.
And so server one goes offline, now client needs to mount. What happens?
If server one is offline and they have set the mount point to be server one, you know, Gluster one, it's not going to work. So you need to point it over to another one. Well, that's a load balancing issue. That's not a Gluster issue. Yeah, this is a file system. Yeah. Yeah, you can do software-based load balancing, LBS or something similar to that. So I really got to move, guys. All right. So how do I connect? Well, you already saw how to do it with the native GlusterFS file system. Mount-T GlusterFS, super easy. If you want to do it with NFS, you have to export the Gluster share via NFS for one of the nodes. So what I did was I actually created an Etsy exports where I did /mount/GlusterNFS. That's an arbitrary name. I just called it that. And then I share it because I'm doing NFS 4. I do, you know, the FSID equals 0 to everyone. Turn on RPC binds, turn on NFS server, start both of those, do a show mount. I've got my Gluster NFS thing out there. From my client, I mount it via NFS. So mount-T NFS, Gluster1 /mount/Gluster NFS, whatever. And then there's all my content there as well. So doing it via NFS, the thing to be aware of is if I do it via NFS, all my reads and writes will absolutely only go to that one machine because we're not doing load balanced NFS. It can be done. It's in the how-to. I don't have time to cover it here today. But it'll absolutely replicate to the other ones. But you're doing a single point of failure, right? Everything is reading and writing through that one NFS daemon, and so it's not going to be as fast. For Samba, same thing, right? You're going to mount it locally, set up the export via the etc samba smb.conf file, and share it out that way. Do be aware, when NFS locking and Samba locking are on top of each other, you can potentially have a bad day. It's relatively rare, but it happens often enough that I got to warn you, it does happen. Okay? All right. Whew. Are these 50-minute sessions or 1 hour? They're 50 minutes, right? Like I'm supposed to get out of here, like, I think now? Got 10 minutes? Okay, cool. All right, other questions? Yes.
So, yeah, are there any, two questions in one, are there any network requirements between the node peers? And also, if one of the peers, if the connection from the client to one of the nodes goes down, but the network is not, but the node is not actually down, yeah, so you lose the connection, not the node.
Right.
Yeah, maybe temporarily for whatever reason. Can another server provide a file from that node?
If it's replicated, yes.
Okay, and then
But you're going to have to reconnect.
okay, but what would be the network requirements between the nodes?
So there's no requirements. These are all on single Ethernet interfaces, right? So the requirement is they got to have IP connectivity to each other. If you want to set it up to have redundancy and high-speed backends and things like that, you can get into the whole 2 NICs, or you could even have one subnet for management, one subnet for presentation to your end users, and then one subnet for backend storage. I've seen environments as complicated as that three subnet environment, but you can do it in something as simple as a stack of laptops with one Ethernet interface each.
But there will be communication between the peers. So even if it's one, how much bandwidth will be? Is there any bandwidth requirements between those peers? Even if it is a single NIC.
If it's single NIC, the only time you're going to run into any network usage is when the clusters are first coming up. They're going to do the the Gluster peer info. Basically, they're going to go figure out what the other guys in the cluster are. So when you first bring it up, there'll be some traffic. But like as the cluster is going, because we're not doing metadata services, we're not having to update each other on what's available. Right? That's the whole point of that hashing algorithm. There's a bunch of benefits to that. Well, when you rebalance, sure. Yeah. Yeah. Well, in that case, if you're going to have a really big complex storage environment, then yes, you absolutely want to have probably a dedicated network for peer-to-peer connectivity for doing things like replication. If you're doing NFS or Samba, you absolutely want to have that replication happening on the back end, not on the network that's presented to your customers. So those would be a good environment for your InfiniBand or 10 gig Ethernet. Yes.
One of your 4 servers, say number 3 goes down.
Mm-hmm.
The primary one you're mounting to, it goes away. You have to fix it to bring it back up.
Mm-hmm.
What do you have to do on the client side to reintegrate that? Or any side, you just bring it back up.
Just bring it back up.
You have to bring the server down for maintenance, whatever. Bring it back up. It automatically rejoins the cluster.
Yep.
Clients don't have to redo anything.
Nope.
Everything's rebalanced.
It's magic.
I love magic.
Yeah, it's not really magic. Yeah, it's not really magic. Now, do be aware that if you are doing a replicated environment, I mean, it will self-heal. But if you have to force, or if you want to force it, like say before you make it available to the customers, then you would do the Gluster volume rebalance. Yeah. Hang on, sorry. Yes. Mm-hmm. Yeah. Gluster is really the closest thing to magic I think that we sell. It is silly easy to set up. I mean, you saw me do that, and I was taking time to talk about every single step. When I do this, if I've got a big enough screen that I can actually do it live with all 4 terminals going, I can do the entire demo in about 15 minutes if I don't stop to answer questions and explain what it is I'm doing. This is the easiest product that we have, and it's fast, man. It is so fast. When you start striping or distributing stuff over 10 or 12 servers, all of a sudden you've got the ability to do multiple streams at the same time, and it's a thing of beauty. Yes. There are times where we've had customers who have taken the I can use old hardware and make it usable too far. What do you mean this PowerEdge 2500 is not enough for what we're trying to do here? You know, come on, dude, really? You know, there are some things like that. I will be the first to say that if you're doing really heavy duty throughput, if you're doing like a big replicated environment and you're doing a zillion little bitty files, performance is going to suck. Because performance on a zillion little files on every file system in the universe pretty much sucks. I've seen it be a lot worse on Gluster, but I've also seen Gluster, depending on how they've got it set up in the back end disks and stuff, smoke the hell out of NFS. So it's really, you're always going to get what you pay for. So if you do grab the old PowerEdge 2500s out of the basement and they're crappy Pentium 3 machines and they've got 7200 RPM, you know, crappy drives, you're going to have a crappy experience. On my crappy home PCs that are literally like, you know, desktop class AMD processors with, you know, minimal amounts of memory, I put some SSDs in there for my back-end storage. SSDs over InfiniBand. Oh, it was awesome. You know, I mean, it's super fast. So it totally depends on how you set it up. Yes. Do you have monitoring applications or visualization? So interestingly, we have a GUI for Gluster. I don't do GUIs, so I don't know that. Right. So, but the cool thing is we've actually integrated Gluster into our virtualization product, Red Hat Enterprise Virtualization. There is a UI in there that's actually pretty sexy that you can go in, like you can go point it at the Gluster environment and it'll like automatically generate your back-end disk images and do all kinds of cool stuff like that. And it does show you graphical representations of like how much is in use and things like that. There are MIBs. I think the MIBs are only available from gluster.org. Like I don't know that we sell, you know, I don't think that we have those as part of, I'd have to look. But I mean, the reality is SNMP can monitor anything. So you, yeah. Right, the MIB. Hang on. Yeah. Yeah, the largest individual file is what you're saying. Okay, yes, that is absolutely correct. So if I have 8 gig bricks and I try to write a 9 gig file, I'm going to be really pissed off at the end of the day because I'm going to write 8 gigs of it and then it's going to go, sorry. Anything else? Yes, sir. Mm-hmm. Don't do that. That's okay. Yeah. You can actually add smaller bricks for distributed. Don't do it for replicated. No. Can you expand a replicated volume? Yeah, I did. I added more bricks, and so it went from 8 to 16 gigs. Or no, I'm sorry. I see what you're saying. Scratch that. No, it didn't go to 16 gigs. I'm stupid. I just added more replicas. Yes, you can do that. What you have to do is you have to do a combination at that point, or the easiest way, I should say, is do replicated, distributed. So you can, I know, it's crazy, but you can actually say, okay, I've got my replicated environment. Now I'm going to distribute that across another replicated environment. So I can have 2 servers over here and 2 servers over here. I got 8 gigs here and 8 gigs here. So I got this thing going and it's doing its thing, and I go, oh, I'm out of space. So I'm going to build 2 more over here that are replicated, and then I'm going to join those together as a distributed. And now I've got half of it on one side and half of it on the other side. One thing. Totally different animals. Lustre is a metadata service driven. It's really even kind of a different use case. It's for more of like the big data type of stuff. This is more for unstructured data, and it's not a good comparison. The two of them are really not the same thing. All right. So it's time. I got to go. I got to get out of here. Thank you guys very much for coming. I appreciate it.